Hi guys, today we're going to learn how to find derivatives and areas in polar coordinates with the calculator. In the following examples, you need to use your graphing calculator and you need to make sure that your calculator is in radian mode, okay? So they tell you that a curve is drawn in the xy plane and it's described by the equation in polar coordinates r equals 2 plus sine of 2 theta for theta that is between 0 and pi, where r is measured in meters and theta is measured in radians, okay? So what do we have here? Stop there and let's analyze what we have. The first thing that you have here, let me redraw the lines here so you can see the axis pretty smoothly here. So you have that's the x-axis, this is going to be your y-axis. So you can see the four quadrants here of the situation. Remember, you have 0 here, this is going to be pi over 2, and this is going to be pi. I'm not including the rest. Why? Because your theta is between 0 and pi. What this is telling you, going back to the toothpick that we have here, is that you want the area of this, let's call it as log, okay, from 0, okay, to pi, okay, so you want that, so let's draw it, okay. So if we draw the situation, okay, the area that we want is going to look very funky, okay, so it's going to look like this, okay. So you can see that this is the area that we care about, okay. So please remember that they are asking you find the area bounded by the curve in the x-axis, okay. So we want the yellow area. What are you going to do? As we were suggesting here with your toothpick, you want from 0, okay, up to not pi over 2 because you have stuff in the second quadrant, okay. So your limits of integration are going to be 0 and pi. It's beautiful because they are giving them to you, okay. So you start with your formula. Area is equal to 1/2 because that's part of the formula, integral from 0 to pi. And then you're going to tell me, so what's going to be the r? Well, the only r that you only have one r in this situation, which makes it beautiful. So it's going to be 2 plus sine of 2 theta and all of this square d theta. Why square? Because that's also part of the formula. After that, you have pretty much all your situation. The only thing, since we're using the calculator, just make sure that it's in radian mode. You are going to plug it in the calculator, okay? So what we're going to do here, you go to calculate, okay? So if this works, okay, so let's thinking, okay, so go to menu, okay, you are going to calculus, okay, so you are going to the integral, okay. What I would do here is I put the 0.5 multiplying this, which is going to be the 1/2 that you have here. Then put the limits of integration 0, and over here remember that you're going to put pi. Use a parenthesis for the integrand, okay, so you can put the square, no problem, okay. So then you have sine, and the argument there is 2 times, I'm going to put x just to make it easier, and I'm going to replace theta for x in this situation, okay. So you have that it's exactly what we have over here. Hit enter, it gives you the value, which is beautiful. So you know that this is going to be roughly 7.0685, and this is going to be, please note that it's going to be meter square. Why meter square? They are giving you the units here, okay. So that's going to be your area. Isn't that nice? Okay, so let's move on to B. They are telling you find the angle theta that corresponds to the point on the curve with x coordinate equal to -1. So you know that you are in polars. Please remember from pre-calculus that polars, you know that x is always going to be r cosine theta. Since in this situation we have that r is going to be 2 plus sine 2 theta, you know that this is going to be equal, okay, to 2 plus sine of 2 theta, okay, times cosine theta, okay, because you are replacing this r. And they are asking you, hey, when this situation is equal to -1, okay. So what are we going to do here? Since you can see that now your equation is pretty much this part, okay, please note that we have a lot of parentheses there, Okay, what are you going to do? I'm not going to do it by hand because the arguments are not the same, therefore this is not going to be user friendly. So what we're going to do here is use your supercalculator here. Okay, what you need to make sure is that you type everything there. Okay, so we go to menu. Okay, now you're going to algebra. Okay, I would do solve. Okay, after that I would put a bunch of parentheses here. Why? Because I already have a lot of parentheses there. You know what I'm going to put there. 2 plus, and then you have that it's going to be sine. The argument is 2x. Please remember that I'm going to replace the thetas for the x to make it easier. Okay, so you have cosine x. Okay, so you're going to equalize all this equation to -1. Okay, comma x. Okay, because I'm telling the calculator to solve it for the variable x. After that, go outside the parentheses, and what you are going to do here, let me show you. You are going to click Control equal. Okay, and you want this bar. Why we want this? Because you know that cosine and sine, they have infinite solutions. So here I'm restricting my x in this situation, or theta, however you want to call it. Okay, to be between 0 and pi, because that's what the hypothesis of the problem is telling you. Okay, so just follow the hypothesis of the problem and you'll succeed here. Okay, so do you see it now? Now you click enter here, and you have that there's only one and only one solution. Okay, so you have that thus. Okay, what's the business here? Your angle theta is going to be equal to 2.6303. Okay, and this is going to be in radians. Okay, so you have that. Isn't that nice? Okay, so sometimes the question seems a little bit funky, but the reality is you already know this from pre-calculus, so it's not as horrendous. Okay, so here I'm giving you the explanation. Okay, so in case that you don't have a CAS calculator and you just have a CX, you're going to draw them, and then you're going to pretty much trace it. Okay, but if you have a CAS calculator, you can see that it's way easier. Okay, now let's move on to part C. They are asking you to find the value of dr d theta at the instant that theta is equal to 5 pi over 7. Okay, and they are asking you, hey, what does this tell you about r, and what does it tell you about the curve in general? Okay, so what are we going to do here? Well, the first thing that you are going to recognize is that r is going to be equal to the same r that we have since the beginning, 2 plus sine of 2 theta. Okay, so that's the r that we have. I'm just copying it from above because it's far, right? But it's the same r. Now, what are you going to do? Technically speaking, they are telling you to find the derivative at a point. The point is 5 pi over 7. So since you have a calculator, use it. Okay, so what you're going to do here is you go to calculus. Okay, derivative at a point. Okay, leave it as x. Remember, instead of theta, we're going to have x. Your number here is going to be 5 pi over 7, right? That's what it was. Yeah. Okay. So okay, and then here you're going to type your expression, which is 2 plus, okay, sine, and then you have 2 times x. Okay, take the derivative of that situation. If you have this is giving you the exact value. So what are you going to do? Control enter, and then you get the exact decimal. Okay, so what this is telling you, and let's label it correctly, is that dr d theta evaluated when theta is equal to 5 pi over 7, this is going to be roughly negative 0.445. Okay, and then since again you have the units in this equation, you have that it's meters per radian. Okay, so but that's not it. Okay, so we already found the value of this one, right? This one check, but what does this tells you about r? So since, okay, what we have here is that dr d theta, okay, evaluated, and let me do the evaluation correctly there, evaluated at 5 pi over 7 is what? This one is less than 0, okay? Why is less than? Because it's negative, okay? They tell you that r, okay, is decreasing, okay, at a rate, okay, of 0.4, what was it, 45 what was it, meters per radian. We're going to say backwards, but no, meters per radian. Okay, so that's what you have. Okay, now we are done with this. What does it tell you about the curve? So it's telling you that this curve, okay, remember your measurement here were always at the origin. So here what this is telling you is that the curve, okay, is getting smaller. Do you agree with that? It's decreasing. So it's getting closer, okay, closer to the origin or the pole. Okay, why? Okay, because you know that the smaller your radius, the closer you are to the origin. Okay, so that's why we are concluding in this way. Okay, so that's for that. Now the last part, it should give you relate rates vibes. Okay, so here a particle is traveling along a polar curve given by the same r that we have since the beginning, so that its position at time t is x of t, y of t, such that d theta dt is equal to 3. Find the value of dx dt at the instant that theta is equal to pi over 6 and make the interpretation for the context of the problem. Okay, so what are you going to do? Before feeling overwhelmed, think about something. This is a related rates problem, so you have here your information and what they want you to find. Okay, so think about that. Okay, so I want to find dx, what was it, dt, and I'm giving, okay, d theta dt. Okay, so if you are given d theta, what was it, dt, I already have the dt here in the correct position, so how can I make it equal? Force it. Okay, so the way that we can force it is dx d theta. Are we okay with that? So this is your related rates situation. Very beautiful. Okay, so this one we have it. Now the business is, can we get this guy? Okay, so yes, we can get it. Okay, so why? You want to get this at pi over 6. Okay, so what are we going to do here? Okay, so you have dx d theta at specifically pi over 6. What's going to be that? You know that x, what's x? X is r cosine theta, right? Okay, so what are we going to do here? Okay, so again, you have the derivative at a point. Okay, so actually, I didn't save it, so anyway, so menu. Okay, so you have the menu again, calculus. Okay, derivative at a point. Okay, here the value is going to be pi over 6. So you have your pi over 6 here. Okay, here what are you going to put? You are going to put two parentheses here. Okay, first you have your 2 plus, what was it, sine of 2x. Okay, and then you have that here it was cosine of x, right? Let's say that you want it in decimal form, so I'm just going to put a dot there so it gives me the decimal. Okay, so you have that this is going to be equal to negative 0.566. Okay, so let's record that. Negative 0.56698, yada yada. Okay, so you have that, but that's not your final answer, that's only a piece. So what I know here is that what do you have here? Dx dt, you want to find it specifically when theta is equal to pi over 6. Do you agree with that? So what you're going to have here, okay, I already know that this one, okay, the theta dt is 3, so you have the 3 here, and then here you just copy all that value that we have over here, and I want to put dot 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 because here you cannot round this one because that's not a final answer. Okay, so let's just copy this one and multiply that guy times 3. So you have that this is negative 1.70096. Okay, and this is meters per unit of time. Unit of time. They didn't share the measurement of time, so maybe seconds, maybe minutes, who knows. Okay, but this is the value that they are asking for. Do you agree with that? Okay, now another thing that you need to check here is that x, okay, evaluated at pi over 6, what is this going to give you? You know that this is going to be equal to what? Cosine Okay, this is going to give you cosine of what was it, pi over 6, okay, times what was it, 2 plus sine of what was it, pi over 6, right, but it was times 2, okay, so we have this equation, okay, so we want to know what's the business here, okay. So what we know, okay, is that this equation is going to be positive because this is in quadrant 1 and this is in quadrant 1, so you know that this is positive. I don't even evaluate that, okay. So you know that this x is greater than 0, okay. So here, okay, what you know is that since dx dt, okay, the one that we have here is negative, okay, evaluated at pi over 6 is negative, okay, and x evaluated at pi over 6 is positive, okay, they have opposite signs, okay, please note that. The particle, okay, the particle is moving, okay, towards, okay, the y-axis, and this is happening, okay, because they have opposite signs, okay, so please note that that's very important, okay. So let's move on to the next example. So for this example, what you have a curve C, okay, that it's defined by the polar equation r of theta equals 2 sine squared theta. Please note that C is this one, okay, they are telling you here in the graph, okay, so great. The theta is between 0 and pi, the curve C and the semicircle, okay, so the semicircle is the one that we have over here, r equals 1/2 for the theta that is between 0 and pi are shown in the xy plane. So you can see that here's the semicircle that they are talking about and the polar curve. Since we're talking about polars, mine as well, I'm going to do 0, pi over 2, and then over here your pi. You know that we're going to be working in quadrant 1 and quadrant 2. Okay, so let's read the first part. Find the rate of change of r with respect to theta at the point on the curve C where theta equals 1.3. So the first question that you might have is which r? They are telling you C, so which one is C? This one, okay? So you know that you're looking for dr d theta evaluated at theta equals 1.3. Now, we already know that we're talking about the one with C, meaning this one. So you want the derivative of this one evaluated at 1.3. I'm not even going to waste my time doing it by hand. I'm just going to go to my calculator. Okay, make sure that it's clean and it's in radians. Okay, in this equation it's in radians. Okay, so let me show you radians. Okay, almost half battery, but in radians. Okay, so what do you have here? Menu, calculus. Okay, derivative at a point. Your point here is going to be 1.3. If you want, you can change that to theta. I usually leave it as x, so change all the thetas for x's. So you have 2 times, and then you have that it's going to be what was it, sine of x and all of this square. Okay, don't forget to put that square that we have here. Okay, okay, click enter and you're going to have some value here. Okay, so copy that value. If it doesn't give you enough decimal places, you can find the decimal places like that. Okay, so 1.031, and that's it. Okay, make sure that you label it correctly and you are done for this part of the question. Okay, we don't have units over here in this one, so I would just leave it like that. Okay, so now let's read B. They are asking you to find the area of the region. Okay, so you know that area, it means that you're going to have the formula 1/2 integral of r squared, okay, of the region that lies inside the curve C, but outside the graph of the polar equation r equals 1/2. So what are they saying here? Okay, so what area we are like looking for? Okay, so they want the one that it's outside the semicircle but inside this curve C, right? So what you want is you want all this situation. Okay, do you see it? Okay, so we want the yellow part. Now, before we start, you're like, what's the business with the limits of integration? Yeah, it's not going to be from 0 to pi. Why? Because we don't have a situation here or here. So you need to find the intersections. That's the first thing that you need to find here when you have a polar and you have two polar equations. So what I'm going to do is I'm going to set my 1/2, why my 1/2? Because it's your semicircle, equal to your C. What's the curve C? You know that it's going to be 2 sine square of theta, and then you're going to solve this, okay, and this is going to give you some values of theta, okay. I'm going to use my calculator, okay. So let's use a calculator, okay. Go to algebra here, okay. Go to solve, okay. After that, well, let me put just 0 and enter. Yeah, it's going to complain. Okay, I'll just remove everything, okay. So we are there, okay. So algebra, solve, and then you have that it was 0.5, okay, or 1/2, however you want to call it, 2 times, and then put a parenthesis. You have that it's going to be sine, okay. At that sign is going to be x, and remember to put the square there, okay. Then you're going to solve for x, so comma x. Outside of this, you know that you want it for a specific interval. The interval that we want it here is from 0 to pi, okay. Otherwise you would have infinitely many solutions, and we don't want that, okay. So 0, and then you want less than. Here we're talking about x, so, and then this one, okay. So you have two values, okay. So over here you have that it's 0.523599 and 2.61799, okay. So what you know here, and by the way, this is pi over 6, and this is going to be, okay, 5 pi over 6, okay, this one, okay. So or this, okay. What we have here, let me get my toothpick, is that your toothpick starts here, okay, and this line that you have over here, let me draw it so you can see it, okay, from the origin there, this is the angle pi over 6, or 0.5235, okay, and this angle that you have over here is 5 pi over 6, or 2.6179, right? Okay, so your area is from here to here. The bad thing about this toothpick is that it's covering this area, this white area that we don't want. So what are we going to do? Well, first you set your area. It's going to be 1/2, and now we know the limits of integration. You can put them in decimal form or with the unit circle values, whatever you prefer, okay. So I'm just going to put them there. Let's say that we start with C, right? So you have that C is going to be 2 sine square, okay, theta, okay, square, right? Square, okay. So this one is going to include the white part. Since we want to remove the white part, this one, okay, this part we want to remove, you are going to have minus 1/2 square. Why 1/2? Because this, okay, the border of the semicircle is the 1/2. Then I put another parenthesis here and the theta, okay. And after that, that should give us the result. Are we okay with that? So now let's plug this in the calculator and let's see what the calculator gives us. Okay, so 0.5. Okay, don't forget to put that 0.5. I'm warning you, I tend to forget that one. So just be conscious that we need to put it there. So I would put the pi over 6. If you use the decimals, try to put all the decimals that you can there, or store the numbers. That's another option that you have here. Over here I'm going to have that it's going to be 2 times, and another parenthesis here. You have that this one is going to be sine of x, and then here is going to be square, but there's another square here, so be careful there, okay, because we have the square. After that you're going to have minus, and then you can put 1/4 or 1/2 square, whatever you prefer, okay, and then the x here, okay. Let me put it here so you can see my integrand and everything, okay. Click enter. You have this beautiful value. We have that value is going to be 2.06677, and that's going to be your area, okay. So here be very careful about the squares, okay, because that's very tricky, okay. So let's move on to part C. Okay, so they tell you that it can be shown that dx d theta is equal to 4 sine theta cosine square theta minus 2 sine cube theta for the curve C. Nice, they are giving you here the derivative. Okay, so let's see what they want. For theta, that it's between 0 and pi over 2, please note that this is just quadrant 1. find the value of theta that corresponds to the point on the curve C that it's the farthest from the y-axis. Ask yourself, what are they asking for? Okay, so they are asking you to do the extreme value theorem. Okay, why? They are giving you, okay, an interval over here, which you know that you need to test the extremes, and then you need to make sure when the derivative dx d theta is equal to 0. So set them. We want to know when this is equal to 0, meaning we are going to solve this again, use the solver in the calculator to find when this is equal to 0. This will give you some kind of theta. So let's plug it in the calculator. Okay, so now you can see how the solver here in the calculator is pretty user-friendly. Okay, so menu, algebra, solve. Okay, so what do you want? You want 0 is equal to, and we want 4 times parentheses. You have that it's going to be, what was it, sine, okay, of x, and then I want another parenthesis there. Okay, so we want cosine, okay, x, and then careful with the exponents there. Okay, square minus 2 times, and that sign is cubed, so I'm going to put it here very carefully. Okay, cubed. Okay, so you have that situation. Okay, so you're going to solve it for x, and that one, let me just make sure that it's, okay, make sure that it's below. Okay, so I don't know if you can see it there. Yeah, you can see it there. Now here we don't want it for all the numbers, we want it specifically in this part of the problem from 0 to pi over 2. So here, okay, let me show you, control equal, and then you're going to have this bar that you have over here. Okay, so you put that bar, the 0, and then control equal, okay, less than x, okay, less than, and then you have that it's going to be pi over 2. Okay, click enter, and you have those values. If you don't want this and you want the decimal, put control enter, and you have your 2 values. Now the 0 is redundant because that's one of the extremes. Okay, so whatever. Okay, so you can write it or not, it really doesn't matter, and then 0.955. Okay, so, or what you can do is, I'm going to copy this here, okay, with all the decimals, and let me remove all of this. Okay, and I'm going to call it a, okay, control variable, and I'm going to call it a. So every time that I call a is going to be this value. Okay, so now what are we going to do? You know that we're going to use the extreme value theorem now. Okay, as the name tells you, the extreme value theorem tells you that we have the theta values. Okay, so my thetas are going to be 0, 0.955, and pi over 2. Okay, and here where are you going to plug it? To x. Okay, what we know is that x is equal to what? R of theta times cosine theta. Okay, so that's something that you know from pre-calculus. Okay, so what are we going to do? You plug this one. Okay, remember, what's R of theta? R of theta is going to be this guy. Okay, so okay, so let me just copy that so you have it handy here. Okay, theta, okay, of this cosine theta. Okay, so this one is going to be 0 because you know that sign is 0, and pi over 2 is going to be 0. So what's the business with the other one? Okay, so what I'm going to do is I'm going to plug, okay, 2 times, okay, and then you have the sign. Okay, what was it? A, right? Okay, we wanted a, okay, square, times, okay, and then you want cosine of a. So as you can see here, okay, you can see that the a's are bolded because I'm storing those values. Okay, so you have that value, so you have that this is 0.7698. Now analyze it, compare them. You have that, therefore, thus the value, okay, the value of theta for which, okay, the point, okay, on the curve is the farthest, okay, is which one? Farthest is the biggest, okay, from the y-axis, y-axis is 0.955. Okay, and that's it for this part of the problem. Okay, let me show you the whole thing. Okay, so for part D, they tell you that a particle travels along the curve C so that d theta dt is equal to 15 for all the times t. Find the rate at which the particle's distance from the origin changes with respect to time when the particle is at the point where theta is equal to 1.3. So what are they asking here? Okay, they are asking you the rate at which the particle's distance from the origin changes with respect to time. So technically speaking, what they are telling you is that they want dr dt. Okay, that's what they want, and you have d theta dt. So similarly to the previous problem, what we're going to do here, you set this, you can see that it's a related rates problem because they are giving you some value and they want you to find another rate. Okay, so what you have is that d theta dt, obviously it's not equal to that, so to force this equation you are missing the dr and the d theta here. Okay, which you can see that if you evaluate each one of this at what was the value of theta here, it was 1.3. What do you have? We do have that this is going to be 15, and this one specifically should look very familiar. Why? Because you found it in part A. Okay, isn't that beautiful? So what we have here is that, okay, let's call it from A. What do you know? You have that dr d theta evaluated at 1.3. We have that this was roughly 1.031. Okay, so what are you going to do here? Well, not much. Okay, so you're going to do a multiplication. Okay, so what you have here is you have that this value, they told you from the hypothesis of the problem that it was 15, and this one it was 1.031 with more decimals. Okay, the only business is here, hopefully you have in your calculator what we got from A. Okay, so where is my A? Okay, so we have that. Okay, so what I'm going to do, I copy all of that times 15. Okay, so you see it that I copy that from, and then you have that this is going to be 15.465, or you can put more decimals if you want to, but you don't need to. Okay, thus what do you have here? Well, you have that the particles, okay, the particles distance, okay, from the origin changes, from the origin, okay, changes, okay, at a rate, okay, of 15.465. And that's pretty much it for this problem. Okay, so remember, if you have any questions or concerns, write them in the comments, and I hope that you find this video helpful. Bye.